Hello, my name is Ulrik, and in this video I'm going to show you how to use some of the basic features of the CImg library, and I'm going to show you how to set up a project in Xcode. If you're on a Mac, you can set up a project in Xcode, and I've made a small video on how to do that. After you set up the project, everything should be similar. And if you're on a Linux machine, then I guess you can just use the GCC compiler. Just remember to include the X11 Windows system. Okay, so let's go. I'm going to minimize this, and we're going to make a new project here. And let's just start with an empty project. I'm going to call it CImg basic. Yes, why not? And I'm going to select a folder that I just made on my desktop. Okay, I'm going to browse for it. Desktop and CImg. Okay. And here we go. So the first thing we're going to do is just to add a file so we can write some code, right? And we're going to write just a C++ file, and it's going to be called source. That's fine with me. And we're just going to write our main function. So int main, int arg c, and const character star star, and argv. And we're going to return 0. So now we're ready. We're going to include the IO stream because we're going to put something out to the terminal, maybe. Include IO stream. Yes, and let's just make a hello world here. So standard cout CImg intro. Standard and line. Good. Let's see if everything works. Okay, so maybe I should have just halted the program a bit, but okay, it did work. So now we want to include the CImg library. So how do we do that? So first we need to go to the website CImg.eu. Please find the link in the description. And we go to downloads and we download the package. We go to the CImg folder and save it. I don't know, just do wherever you like. We go into the downloaded package and we collect the header file. So the cool thing about this CImg library is that it only needs the header file. That's a huge advantage, I think. So you don't need to worry about any dynamic linking and stuff like that. If you just want to visualize something quickly, then you can just use this. And we're going to copy it into our project folder. And then we can add it to our project if we want to, and we can choose not to, but I'm going to add it. Existing item, like this, and then I'm going to include CImg.h. Very good, now it should work, so let's do a quick test. CImg library. And we're going to make an image, and the image type in here is called CImg. And then it's templated, so we need to choose the basic type of this image. It could be so one thing that is quite common is to choose unsigned characters. So this is 1 byte. So we have pixel values going from 0 to 255. And we're going to make an image called, this could be the background image. So BG. And this background image should have a width and a height, and I'm going to specify the width and height. So int, well, maybe it's unsigned int width 300, unsigned height, unsigned int age, and it could be a little bit taller, maybe 400. Let's do this. And in the constructor of this image type here, we're going to write the width and the height. And the CImg library expects like a 3-dimensional image. So we also need to specify depth of the image, but we're only working in 2 dimensions, so the 3rd dimension should be 1. And then we need to specify the number of color channels, and let's just work with 3 for starters. And now if we want to, we can fill the image with some color or with some pixel value. So if I write like 255 here, it should be white. So we have a white background. Okay. And so now this is an image, and you can see it becomes a little bit tedious with this CImg library prefix everywhere. So we can remove it and then just use the namespace here. Using namespace CImg library. Cool. And now this should work again. Very good. And maybe we want to draw something on this image. And let's try to draw a circle on the image. So we write bg.draw circle. And we're going to specify where this circle should be. So let's put it in the middle. W divided by 2, h divided by 2. And then make a radius, maybe 100 pixels. And the color. So it says a parameter pointed to spectrum consecutive values defining the drawing color. So what does that mean? That means we need to make an array with unsigned characters. So let's do that. Const unsigned characters. And let's call it, what color should we do? Let's do it like a blue-green color, maybe, just to show you guys how this works. And red, green, blue, so no red in this, some green, maybe like 170, and a lot of blue, 255. Okay, so let's make the circle blue-green. Okay. So now we have a white image with a blue-green circle in the middle. I think we can display it right now, so let's just try to do it like this, display. And I don't like doing it this way, but it should work. And I'll tell you in a minute why I don't like to do it this way. No, I'm going to tell you now. You don't really have too much control over this kind of display. Okay, so you can see the image here. So we did draw it. So we can do zooming and stuff like that. And I mean, I want to have more control over how this is drawn. So this, I think also this is basically for debug purposes mainly. So what I really want to do is to make a display, and the CImg package also comes, well, the CImg library also comes with a display type, and it's called CImg display. And let's call it DSP. And it also has a constructor, and we need to specify the size, so the width and the height, and also a title. Let's call it hello. And we need to specify the normalization type. So if we write 0 here, the image is just shown as it is. And if we wrote 1, for instance, then it would sort of normalize the colors, so that if the image is very dark, it would scale up all the colors, so it would also have bright colors in it, or be shown that way. But we are not interested in that right now. So now we have a display, and we can display our image like this. We use the display, and it has a method called, well, display. And we just write the image here. So BG. Yes, and let's just see that. Oh, that went away quite quickly, right? And that happened because it sort of just ended the program right afterwards. So let's try to hold the program a little bit by using a standard get character. And then it should be halted, and we can see what's going on. Very good. Now I have a display which I've perfectly specified myself. Okay, so this is the main functionality of the CImg package, the CImg library. But there is one more thing that I would like to show you. We have this, often we have like an event loop. So let's try to do this while. And this while loop is going to run for a while. It's going to run until we close down this display. So we can say while DSP is, can we say open? No, we can say closed. And of course we have to invert this, so it's going to run while this is not closed. And in the end of this loop, we're going to wait for something to happen. So we say dsp.wait. Okay, so this one just waits for maybe the mouse to pass over or something like that. And now we want to do something to the image and display that. So what I'm going to do here is to make another image. Sorry, like this. And this image is going to be called CImg, why not? And this is good. I think we can just pass the other image into the constructor and it knows what to do. It's just going to copy it. Yes. And now I don't want this is going to be the background image, and I don't want it to be a white background with a circle in the middle. I want it to be, maybe I just want it to be a blue-green background altogether. So instead of a circle, I can draw a rectangle, and the rectangle can occupy the entire screen. So 0, 0, comma width, comma height, and it's going to be blue-green. I think this is how it should be. Yes. And here we copy the background, and now we can do some drawing on it. So maybe we want to draw a circle where the mouse cursor is. So how can we get access to the position of the mouse cursor? So let's try to write the dsp.mouse x mouse, like this. This is the position of the x position of the cursor. So let's call it xm, and that's an integer. And let's do the same for the y direction. Y m mouse y. And let's draw a circle. So we write, so in here we're going to copy, let's just do it like this. CImg dot draw circle. So xm, y, m, and we need to choose a radius, just take it 15 maybe. And we're going to have to choose a color for it. So what goes to nice to a blue-green color? An orange maybe? Orange. And so let's define our orange color here. orange. And what is orange? It has a lot of red in it and also some green. Not too much though, maybe 140. I don't know, not any blue. We might also want to add some other colors, maybe a white color. It's going to be all 255s, and maybe like a black color too. That's all zeros. Black. 0, 0. So now we have all the colors that we need. And okay, draw a circle, orange. And we're going to display the image once again. So dsp.display img dot no dot, just display this. Okay, I think we're good now. Let's see what happens. Yes, okay, so it draws circles where my mouse is, but you can see that everything stays on the screen. And this is also to be expected because, okay, I have to close it like this. So why did we expect that? We expected that because the CImg image is constantly being drawn to, but it's never sort of reset. So we can just set it equal to the background every time we start, every time we go into this loop. And we can run it again. And then we should see that the circle is just where the mouse is. Yes, very cool. So maybe we want something to happen if we click. Now nothing happens. So let's try to see the mouse control here. So how do we do that? Maybe we want the circle to change color. Yes, and maybe also size. Let's change the color. Okay. So now instead of actually writing orange explicitly here, we just write a pointer to a color. So const unsigned character pointer, and just call it col. And it can be set to orange. Okay, orange. And this is called col. Okay, now this should do the same as before. But then we can write if dsp.button. And this function returns 1 if it's the left mouse button which is clicked, and it returns 2 if it's the right one, and it returns 4 if it's the middle one. So basically it's the first, second and third bit in here. That's quite convenient for some purposes. So now we're going to make a bitwise AND operation with the first bit. So if this returns something non-zero, then we're going to say that we left clicked. And in that case, we want to change the color of the circle. So maybe col is set to white instead. And we can do something like this. If we hit the right button, we're going to make it, which one did we have? Black. Yes. Very good. Let's try this. Okay, now I left click. Okay, so it becomes black always. Oh, I wrote 3 here, I need to write 2. 2 is the right button. That's how it is. Okay, so this is left clicking, And this is right clicking. Very cool. Okay, it works. Now we could also change the size. That would be kind of nice. But it doesn't matter now. Let's not do that. So the last thing I want to maybe show you is that we can also access, if the keyboard is pressed, we can also know about that. So if we also make another condition here, so we only keep going if the keyboard, if escape is not pressed. Okay, so if we press escape, we want the window to close. So we write dsp dot iskey. Does it have? Yeah, we need to underscore here. Iskey, ESC, like this, and basically it knows all the keys. You can also write like A, so if A is pressed, then it will know about it. And let's just write here. Okay, it works, and if I hit escape, it closes. Very nice. Hello, thank you for watching. If you like this video, please subscribe to my channel. I'll definitely be making more videos using the CImg library, and also I'm going to make some cool videos with physical experiments and also maybe some simulations. See you next time. Bye.